Okay, on to example 2. So let's take a look at it. Again, we have two triangles, two right triangles, A, B, and C, and A, C, and D. And what they're asking us to do is find the length of side BD. Okay, so they're asking us to find from B to D. So that is our chore to find how long that is. Now, you can see to the side I have a hint. Now, the hint might work for this one and it might not. So let's see. It says, if the triangles share a common side, you would likely need to find its measure. Okay, well, the common side is AC, so I might have to find that. I'm not sure. Now, this does create one large triangle, but the large triangle here um, is not a right angle triangle. The large triangle is made up of two smaller ones. Now, are there other laws that deal with non-right triangles? Yes, there are. However, what we have going for us right now is only the primary trig ratios and other geometric properties. So I'm going to look and follow what we said with our last page, that I'm going to find as many angles as I can. Because if I can do that, then maybe I will be able to find enough information. Okay, now because we want to find BD, and that is the length of the large triangle, and I don't have skills for that, I'm thinking I'm probably going to have to, and I think I have a highlighter here, is I'm going to have to find uh, BC. This is just what I'm thinking. And then I'm going to have to find CD and then take those two and add them together. That's what I'm thinking I might have to do. I'm not quite sure until we actually get started. Okay, so first of all, we're going to label as many angles as possible. So I'm going to look at ABC first, that triangle, and see what I can find in it first. Okay, so I know I have two triangles. So the first one, and I've got to go back to a writing pen, and let's use purple for a change. Okay, so I have two triangles. The one triangle is triangle ABC, and the other triangle, I'll just put it here, is going to be ACD. So those are the two triangles I have. In the first one, I can calculate angle B because it's going to equal the 180 minus the 90-degree angle minus the 12 degrees. And so we end up having this is equaling 78 degrees. Now I could have just gone 90 take away 12 to get that. That would have worked as well. So I know that this is 78 degrees, so that's important, maybe. And now if I look at the other triangle, there's one angle I don't know here, and that's angle A. So I could calculate angle A. Angle A would equal 90 minus 28. So I don't know if I'm going to need that, but at least I'll have all the angles found. So when I do that, I end up with 62 degrees. So that's 62 degrees. Now, if you notice, remember I said that I thought maybe I would need to find these highlighted lines separately. Well, let's take a look at this first triangle. Do I have enough information to actually solve for BC? So if I'm interested in this, and I'll call it X, do I have enough information? Well, let's see. So I'm going to switch colors just so we can see. So here is my angle. This would be opposite. This would be the hypotenuse, and this would be adjacent. Now, I could use the 78, or I could have used the 12 that they gave me. Either way would have worked. I could have used the 12 to find that. So, as I said, it doesn't matter which one you use. So if I look at SOHCAHTOA, what one am I going to use? And I'm just going to run through this really quickly because by now, hopefully you've figured it out. So I'm given the hypotenuse and I want to find the adjacent, so you can see right away I'm going to use the cos. If I use the cos of a theta equals adjacent over hypotenuse. And I know that my theta here is 78. My adjacent side is the one I'm going to find, my x, and I'm given the hypotenuse. So again, when I cross multiply, or if I multiply by 14, I get x equals 14 cos of 78. And what we get here then would be approximately 2.9 meters. That's a 9, by the way. Okay, so I found BC. Now, if I look at the other triangle, do I have enough information for it? I think I do. So again, I'm going to switch colors because it does get quite messy. And so this would be another example where you could actually draw some more triangles. So I'm going to use my 28 because that's the one that's given to me. This is the opposite side for it. This is the hypotenuse, and I want to find this side, which I'll call y, which would be the adjacent. So again, if I use SOHCAHTOA, back here you go, please. Now, notice I didn't have to use the 62 that I found. Did it hurt me to find it? No, it didn't. How long did it take me to get it? Not very long. Okay, so we got SOHCAHTOA. And I have the hypotenuse again, and I want to find the adjacent. Oh, amazing, I'm using cos again. So I'm not going to get the same answer because I'm using a different theta this time and a different hypotenuse. So adjacent over hypotenuse. So I have cos of 28 equals adjacent, which is y, over 67. Again, if I cross multiply, I would end up with y equals 67 times the cos of 28 degrees for a grand total of 59.2. So now I have all the information I need. So I know that BD equals my 2.9 plus my 59.2 for a total of 61.1, I believe, meters. You can recalculate that. When they're so far away from me, I just can't see it. Okay, so last question. As the sun is setting, the angle of elevation to the sun from ground level goes from 32 degrees to 27 degrees. During the time, the shadow of a tree, actually not with lengthen, will lengthen. That should be will lengthen. By how much does the shadow lengthen if the tree is 18 feet tall? Okay, so what's going on here? Well, it appears that I have a sun in the sky and it shines. And in my picture, I have a tree. Notice my tree. Yes, I know it's beautiful. And we know that we have ground, and within the ground, we're going to have a shadow going on. So what's happening here is, oops, that's not what I want. So what's happening here is I do have a right angle triangle as much as possible with a tree. Okay, I know that that tree is, according to this, is 18 feet tall. So I can put 18 in that location as soon as I get. So this is 18 feet. And I know that it creates a shadow depending on the time of day. At one point of the day, it creates an angle of elevation, which would be this here of 32 degrees. And then at another part of the day, the tree doesn't change height, it becomes 27. So it changes over time. So let's put those actual things in there as well. Get out of there, pen. So we have this as being 32 degrees, and then as time goes on, it goes to 27 degrees. And what it's asking me to calculate by how much did it lengthen its shadow. Okay, so that's the distance here is what I'm after. Now my problem is here, I do have two right triangles, and I'm just going to use the magic pen just so that you can actually see it without it getting too cluttered. So here is one small one, okay, and then there's another one. Notice they share that line there, the 18 feet, and it's this one. Okay, so we do have two right triangles. So when I look at this, I have to come up with some kind of plan to get the length of this. Now, if you look at the last question that we did, we had to find the whole length. We had to find from here to here. Okay, now this case, we just want part of this. Okay, so what can I do? Well, I maybe could find the whole length in this case and then subtract a length. Okay, so sometimes I have to add, sometimes I have to subtract. Now, before I start, I'm going to label my triangle with letters to make my life a little bit easier. So let's label, and again, it doesn't matter what letters you use, but it just makes it a little bit easier to discuss things if you have something down, so you can tell the person exactly what part of the diagram you're looking at. Okay, so if we look at the first, I think I'm going to call this top of the tree A. We'll make this B. We have C and D. Okay, we don't have to be super creative with our letters. So the first thing I'm going to do is I'm going to look in this triangle here, A, B, C, the small one. Okay, and I'm going to find the length of, I think I'll find the length of B, C. Maybe I could look at ABD. So let's look at that one first, maybe. So again, it depends on what you want to do first. So we know we're going to have to look at those two triangles. So I have to look at some point at triangle. Oh, sorry about that. This just doesn't want to work for me tonight. Let's go back up here. So I know I have to look at triangle A, B, C. I also know I have to look at triangle, and I'll just put it down here, the large right angle triangle, triangle A, B, D. So it doesn't really matter which one we look at first. So if we do look at the small one first, what we can see is if we redraw it, and I'm just going to, again, make the computer give it to us. Okay, so here it is here. We know that we have this is being the 32 degrees. Our tree is 18 feet tall. And if I could find this length, y, I might be able to then use it and find the other and subtract. Okay, so same kind of process. I'm going to circle this, label the triangle. So this is opposite, hypotenuse, adjacent. You can see I have the opposite. I want to find the adjacent, so that's tan. If you don't see that, you can use what the method that we have been using already. So we have tan of theta equals opposite over adjacent, which is tan of 32 equals opposite, which is our 18 over our y, which we want to find. So I'm just going to pause the video here and then take off and finish this question up.